This lecture is on coordinates and level sets. So let's begin. In single variable calculus, we have y is a function of x. So the coordinate system for that, of course, is the xy Cartesian coordinate system. And we call that R2. The x coordinate is one real number line, and the y coordinate is the second real number line. In multivariable calculus, we have z is equal to a function, we'll call it g, of x and y. And we call that R3. Okay, R3 is commonly known as space. R2 is called the plane. Okay, now there's one more that we cover in this class, and we'll say the variable is w, and that's a function of x, y, and z. And that, of course, is R4, three independent variables and one dependent variable. So if this is space, sometimes we call this hyperspace. All right, most of the work we're going to do in this class is going to be in space. So let's begin with that R3. The coordinate system looks like this, with the x-axis, this is the origin, the y-axis, and the z-axis. These are positive numbers, so you have implied here the negative x numbers, positive y, negative, positive z, and negative. Okay? Now, z is perpendicular to y, and you can think of x as coming out of the board. Okay, so x is perpendicular to y, and x is perpendicular to z. So, to identify a point, say the point 2, 3, 4, we have 2 units out in the x direction, 3 units to the right in the y direction, and 4 units up in the z direction. And we usually draw things with a rectangle. And that rectangle is going to look slanted because we're drawing 3 dimensions on a 2-dimensional board. So this line is parallel with this line, and this line is parallel with that line. So this point here would be 2, 3, 0. And to identify this point, we just take these 4 corners and draw a line 4 units up. So up 4, up 4, up 4, up 4. And now we're just going to connect the dots. And I think you can see that this point here is in fact 2, 3, 4. All right, let's move on. Let's say we had a particular function, and it's going to be z is equal to x squared plus y squared. We call that a paraboloid. It's a circular paraboloid. And it looks like this. It goes through the origin here, and it's a surface. Okay, it's like a bowl, and it goes on, forever. All right. Now, many times what we do with surfaces like this is we slice them horizontally. So maybe at z is equal to 1, if we sliced it, you would see the intersection of that plane z is equal to 1, and the paraboloid is going to be a circle, okay, and so forth. We'll do more of this later. This is just an example of what surfaces look like in space. All right. Level sets are ways to picture R3 using R2. Picture things in space by looking at them in the plane, and R4 in R3, and so forth. We'll only cover these two situations in this course. So, R3 going to R2, what does that look like? Well, once again, we'll use that function z equals x squared plus y squared. So we already know what that looks like. It's a paraboloid. Okay. So we're in R3 here. Over on this side, we're at R3. And we're going to slice it. So we're going to have that circle. So we're going to say z is equal to 1. Well, if z is 1, then x squared plus y squared is 1. So we write that over here. X squared plus y squared is equal to 1. And we'll draw it in R2. Alright, well this of course is a circle centered at the origin with a radius of 1. So this circle is associated with z is equal to 1. So let's now say z is equal to 4. And I'm picking perfect squares for a reason. If z is 4, then x squared plus y squared is 4. And that, of course, is a circle centered at the origin of radius the square root of 4, or 2. So we can say that this outer circle is associated with z is equal to 4. And of course, we'll do one more, 9. It's going to be a circle of radius 3. And this guy is going to be z associated with z equals 9. Okay, so we have 3 curves here. These 3 curves are called level sets. Put that over here. And specifically, because they're curves, they're called level curves. Okay? And some books call them contour diagrams. But more properly, they're level curves, which are special cases of the more general level set. So we did R3 going to R2. You can just look at this and say 1 up, 4 up, 9 up. So this really is that paraboloid from a different perspective. We're looking kind of down on it. All right, now we'll do R4 to R3. R4 to R3, and I'm going to use a similar writing on a ink. W is now a function of x, y, and z, and I'm going to write it x squared plus y squared plus z squared. Now this graph in the x, y, z, w coordinate system, you can't really draw. But we can use our trick of level sets. We're doing level sets again. And say, what about when w is equal to 1, w is 4, and w is 9? Well, if w is 1, then over here we have x squared plus y squared plus z squared is equal to 1. And in space, this, you'll probably learn this later, this is a sphere of radius 1. And we're going to associate this sphere or surface with w is equal to 1. And of course, if it's 9, we're going to get a sphere of radius 2. So this is associated with w is equal to 4. And similarly, a sphere, w is equal to 9. So these are 3 level sets. Because they're 3 surfaces, we often call these level surfaces. Okay, that's pretty much what we cover in this class associated with level sets. I just want to point out one more little fact. That'll be more useful later on. If we had a function x, y, and z, okay, and we'll call that w. So 3 independent variables, 1 dependent variable, so we're in R4. If we can write z as a function of x and y. So if we can write z as some kind of function g of x and y. Okay. In other words, if we can write it explicitly, then we can write this function as g of x, y minus z. Okay, we can just break it into 2 pieces. Now, why this is important is, what if we took level sets for w? And let's in particular set w is equal to 0, a special level set. That means this is equal to 0. And of course, if this is 0, we can write that as z is equal to g of x comma y. So the point is, if you have 3 independent variables, and you can break it into pieces, and we take a specific level set, the 0 level set associated with the dependent variable, then that level set is exactly this surface. Okay? And we'll use that later. That's it for this lecture, and I do thank you.